All right, let's conduct another example where we solve a problem using tree diagrams. So a box contains 5 good light bulbs. I'm assuming these are the green ones. And 2 defective light bulbs. Bulbs are selected one at a time without replacement, okay, until a good bulb is found. So I want to find the probability that the number of bulbs selected is either 1, 2, or 3. And I think we should draw a beautiful picture. Wonderful. So I draw out a light bulb. I got 2 options, defective or good. How many good light bulbs do I have? Well, I have 5 out of 7 good light bulbs. So the probability of drawing a good light bulb is 5 out of 7. And the probability of drawing a defective light bulb is 2/7. I'm probably going to say bad instead of defective a bunch, because if you've got good, don't you feel like you should also have bad? Balances out. So I put my probabilities here. So the probability of drawing a defective light bulb is 2/7, and the probability of drawing a good light bulb is 5/7. But once I draw a good bulb, I stop, right? Bulbs are selected one at a time until a good bulb is found. So this root of our tree right here is done. Next, I drew a defective light bulb, so I have to draw again. The probability of me drawing a defective light bulb again is no longer 2/7. It's not 2/7 anymore. What is it? Well, if I drew a defective light bulb, how many defective light bulbs do I have left? I have 1. And how many are in my box? 6, right? I already took one of them away. So I've got 1, 6. The probability of drawing a good light bulb is, if I have already pulled out 1 defective light bulb, is 5 out of 6. If I draw a good light bulb, I stop. But if I draw a defective light bulb, I gotta keep going. So here, if I'd gotten this defective light bulb again, this is a really kind of funny way to pick light bulbs. I'm sorry, so many of these probability questions are just very silly. So, how many ways can I draw a defective light bulb? Now, I can't. All I'm left with are good light bulbs. Thank goodness. So, probability of drawing a good light bulb is 1. So, if I wanted to calculate the probability of just having to draw 1 light bulb, that's here, right? We drew 1 light bulb. Maybe I should draw a light bulb, not a number. Oh, that's a terrible light bulb. I am in a silly mood, guys. Okay, so it's 5/7. That's the probability of drawing 2 light bulbs. The probability of 1 light bulb. The probability of drawing 2 light bulbs is, you're going to want to multiply 2/7 times 5/6. That gives you 10/42, which simplifies down to 5/21. Okay, so the probability of drawing 1 is 5/7. The probability of drawing 2 is 5/21. Now I got to figure out the probability of having to draw 3. That's going to be 2/7 times 1/6 times 1, which gives me 2/42, which is 1/21. And as I have it all worked out for you, so you can check it in the PowerPoint. And here's our tree diagram. I do mine from top to bottom because I feel like that looks more like a tree, maybe more like roots. But if you want to do them from left to right, feel free.